I'm an associate professor at ICADE of Business Analytics. I'll let you know a little bit more about myself in the first place, and of course about the course that I'm teaching. Also, I guess my background is interesting in how I get to start teaching business analytics, which is the name that we give it in ICADE, but of course, for the most part, is how to apply effectively machine learning techniques to solve business problems. All right. You've heard great presentations so far, so I'll try to present new findings, new insights to the extent that this is possible. But again, as a little bit of background about myself, I must say I'm not a professor by training. Let's say I'm not the typical professor that you can find. So I'm much more a practitioner that turned into teaching business analytics as a result of my experience precisely with BigML. I have a disclaimer slide later on, just so everybody knows that I've had a strong affiliation with BigML. So my arrival point to teaching business analytics was actually my experience with a venture I was part of with BigML, building pre-series. I'll let you know a little bit more about it, but that's sort of my arrival point. Before that, I'm an investor in the first place as a private equity investor, latest years as a venture capital investor. For those of you that are not familiar with the industry, that means investing in startups, not only related to data and machine learning startups, but in general. I'm also an MBA from MIT, where I also, of course, I learned some of the orientation that business schools are starting to have towards teaching data and machine learning courses. So this is the disclaimer, right? I know the BigML team and I've worked with them, and I think the product that they have is really good for, of course, a number of technical reasons that I am in no position, obviously, to. I'm not such a big expert, but from the topic that we're talking today, I think it is very, very relevant. So they focus on the right things that you need to, that in my opinion, you need to look at when teaching or when creating a product for business managers, for executives, for actual implementation at the enterprise level. And they focus on simplicity, as Jan was mentioning before. That doesn't mean at all that's actually much more complex than building something unmanageable that requires deep and domain specific knowledge, right? So it is something that, even with enough familiarity, you feel empowered to use, and that's great. And then touching on what I'll let you know are my goals for the class, but touching on preventing that it's been called in the industry, right, like machine learning charlatans. So for making sure that whatever you come up to, you also have the tools to make sure that it is relevant. Okay. This is a little bit on pre-series, which I think for the sake of using the time in the most meaningful way for you, we'll skip that, right? So this is a little bit of the agenda, right? So we'll start by a section called setting the right expectations for the course. So what I tell students they should expect, or that I'm expecting from them during my course. A little bit of theoretical background plus hands-on experience, meaning even if the focus of the way I teach this topic, again, to business students is highly hands-on experience. So we'll do sort of like a business case at the end of my session, but basically grab a data set and experiment, right? Build models, evaluate models, reiterate, try new features, and the like. I do think there's the need to understand a little bit when you're doing clustering, what at the high level you are doing, right? So during the course, we do touch some concepts, right? So, there's no need for you to explain completely what Euclidean distance is, but it is nice that you have an understanding of the concept of distance between two rows in your data set, right? So, and if they're far or near, a little bit what does that actually mean, right? Then we'll touch on why BigML is at the core of my teaching experience. We do use some other software, mostly for the data exploration part, meaning mostly Tableau. for data representation, creating maps, creating sort of different charts. We do use that as well. And a little bit, what would a typical exercise be like at my class using BigML? All right. My objective in the class is to teach students and sort of infuse students with the ability to approach any problem data analytically, right? And what this means is not systematically jump into there has to be a model that solves this 95% accuracy, right? But rather whether and how data can be used to improve if it's a problem or if it's a situation that can be, or if it's just something that can be improved. It is not necessarily a problem, right? So, but literally become obsessed with this ability to look at the wall, see problems, and see possible uses of data at the beginning, right? Just see if the data could be used to support or to solve that problem. Then the other goal for me is to uh, help them be able to interact competently on the topic, right? So basically know about the processes, know sort of the high level practices. Ultimately, we're teaching uh, business students, so not developers, and not even developers, not people with a strong technical background, and that's fine. And I think that one of the things that at business schools we must be sort of strong teaching is, it's okay to be to have a business background, in the same way that not every executive at Twitter or at Facebook, or maybe you don't know all the details of the web protocols, or in general how all the web programming works. You don't need to be an expert. So there's it happened to me as I attended MIT. Of course, you have a little bit of imposter syndrome, right? So there's all these smart people, even here and there some Nobel laureates, and I'm just talking about these things. It is fine. Ultimately, as it's been mentioned in other presentations, ultimately this is the most difficult part in terms of implementing or putting machine learning models into production is the domain expertise related, or is domain expertise related, right? So there's not just one single person that can implement machine learning models in the insurance world, in the agriculture world, and in the banking world. So it's fine. We still need business people, only we need business people that are competent to interact on the topics, right? So that's why the technical part of the course is also there, right? And then my third goal is to actually do it, right? We don't put models into production, let's say, because it requires a different skill set. We get very close to it, actually, right? So from the data collection, building the model, evaluating the model, and ultimately making sort of offline or out of deployment predictions just with a new instance, and we make a prediction, right? So ultimately, what I teach them, it would be as simple as just putting that model and that new sample that you're bringing in for prediction into a front end, right? But we get as close as you can possibly go with no technical background, which is, of course, some of the great things, and what I like the most about BigML. You can get this far with very little coding experience. Maybe you want to do some data transformation, and for that part you may need a little bit of SQL type or Lisp type programming ability, but very little. Why I think this is important for again, as professors, as universities, right? As part of the university body, students are demanding more and more to be trained on this topic, because data related jobs are growing in demand a lot worldwide, right? They have been growing a lot, but we were at the point where maybe this was something like new to have and a nice thing to have for you to differentiate, but it's becoming something like you cannot right now go into an organization, pretend to be a product manager, and have zero familiarity with data management and machine learning techniques, right? This is just something that it is more and more becoming a from a nice to have to a must have, right? And this is happening. Well, the chart that I was showing you is in Australia, but it is happening worldwide, right? So this is data from Indeed on the number of job postings, but happening, right? That's why, you know, some schools, and I can talk from ICADE, and I can talk from MIT, which is another school that I know quite well, are making strong commitments into teaching data science related topics, or both at a more technical level, but also at the business level, right? So on the business level, right now, one of the it is actually competing with the MBA, which is sort of the flagship program of a business school at MIT. MIT developed something called the Master of Business Analytics, so MBA, right? Which is sort of challenging, right? The reign of the MBA as the top program there, right? Because people increasingly want the specialization in the topic. Even the MBA, of course, program at MIT has tons of courses and in the topic, and that's why I think MIT has stayed a little bit ahead on this topic on education of data and analytics courses, right? So something also important, I guess, for students, in order not, because you have different types of students, right? So on the one end, that sounds very interesting for some students, but at the same time, students may be afraid of taking such courses, right? Because, you know, I'm not an engineer. This is a typical pushback when you're very excited and they say, this is stuff you should know. This is stuff that's going to make you much more powerful in your ability to create your own job or to find a new job, right? So I also like to say, which is the no goal, right? The no goal is, this is not a computer science class, so this is not my class is not machine learning for technical students. It is not either a math class, so again, you need to understand what entropy means, just because it's much easier then to understand other topics, and it's as a high level concept. It is not that complicated to understand, but we won't go into all the details of the statistics behind this area of knowledge, right? And I think it is important. You want to focus. Ultimately, you have a small number of hours, and you have you know, a small amount of attention, let's say, from your students, and you really want to focus on what can be the most impactful. Okay, and it is not either a course on big data technology. There's just so many, and too difficult to understand them all without the necessary background. So although we may maybe present so that you have an idea of the map of technologies, I don't think it is useful to spend a lot of time on them, right? At the same time, what I mentioned before, right? We don't want, so getting a high level idea of things and not getting into deep computer science concepts, deep mathematics concepts, or data technologies. What we really want to do as professors is prevent our students to become charlatans, and I think that's something that has been hurting the community. You know, just talking about one afternoon without further analysis or without further questioning, you claim to have built a model that performs, I don't know which number, probably above 100%. You know, you fail to split, right, between your for example, your training and testing data, right? So you use the same data that you use for training the model, then you use it for testing your model, right? And so there's a stuff that I think we must be very strict about, right? And then there's other things that, in my opinion, that are relevant for the for those that are building the tools. It's relevant actually ultimately when you put a model into production. So in the team there has to be someone that has these abilities. But as you are training executives, or as you are training business people in general, I think it is good that you have an idea of the key aspects of any data science project that you need to be taking care of, and and if possible, know the questions that you have to ask to the rest of the team, right? And definitely, in our each of us in our walls may have seen this type of people, right? That with very easy solutions to things that we know it's hard and require a lot of back and forth, and requires continuous sort of feed from what you're actually seeing in production, and continuous questioning and why is it so good, and things like that, right? And are very sort of outcome oriented. Okay, so what should be the goal? I guess the goal, in my opinion, hence, is to know this time, know the processes, right? So this is the CRISP DM methodology, right? We've seen this before today. There's these initial steps: business understanding, data preparation. Part of the data preparation, of course, requires some ability to do data wrangling. But the very first two, a little bit combined with the three, right? But this very first phase, I think, is an ideal area for business students to focus, right? So when starting any project, business standards in the first place for a reason, and then there's this communication between, okay, so business understanding, data understanding. If the data is not sort of supporting the business understanding, right, get back and start all over again. But the business understanding has sort of two rows flowing back, and for a reason, and that's because this is an iterative process, right? And setting the right expectations and focusing on what's really the most important things for the business, it is actually very important. Otherwise, we have a very good model that fulfills no requirement or no need, right? So I think that's an area where I try to tell my students that it is very important to focus. Modeling is very cool, and the evaluation is very it's sort of exciting to see how well it actually performs and do the tuning and all that. But many projects fail because there's no clear understanding of what we want to achieve, and if we want to achieve it's useful for the business, if it's worth putting all that resources and money, and if we have the data to support that, and what can we do if we don't have it, right? And those are essentially the territory of a business manager, and we do need to educate individuals that feel familiar and comfortable and that enjoy doing this type of tasks. Okay, so how do we start? One of my essentials is to develop the habit of data understanding, right? See every problem from a data or analytics point of view, and actually the best way to start is, okay, with the data that we have, just plot it, right? As Kasi Kosirkov, which if you don't follow her, I do recommend you to follow her. Just plot it, right? Don't jump into modeling without actually understanding your data, and sort of finding the first signals of what the data that you have could point you, even before sort of applying more sophisticated techniques than just your visual analysis, right? But it is, and for that, BigML has some visualization tools. Sometimes we also use Tableau or Power BI. The other sort of good practice that I think, or the other learning that I think it's important for them to have is that ultimately we're making inference, right? So when developing a model, you're just making a prediction, right? So it's a it's a statement about something that you cannot know for sure, right? And I think that's important. That's as good as we can get. So we have a bunch of data and some assumptions, right, of our business problem, and with that we make a prediction. And I think that's important to have. I experienced it firsthand, right, when building pre-series, where we made predictions on if companies were going to be successful or not. And this is as good as we get, right? Ultimately, we need to teach business students that data science is just it's just a way to it's a framework, right, to help you make tough decisions or thoughtful decisions, if you want, under extreme uncertainty. But it is a framework, all right. Okay. So the way the class is structured is again this technique or theoretical part together with a group project. We go all the way from the CRISP methodology. You find a business problem that you want to focus on. Of course, we would use KD nuggets. We would use Kaggle. We would use any data repository. BigML has a great, I'll jump in a second, a gallery of data sets that are a great way to start. And then we'll do a number of presentations following, let's say, sort of the steps of the CRISP-DM methodology, right? So the data preparation or data cleansing work, since we pick already sort of data sets from galleries or from repos, most of them are already sort of ready for analysis. So that part we skip it. Typically, it's not the part that a business manager do. But then we would go through picking the right model, maybe changing the type of model, changing the objective function, so that they can experiment different types. Right? This is a little bit screenshots from BigML, right? So from all the way from here, you can see all the data sets. Then how to build a model. We will go through that in a second. The confusion matrix. This is one of the screens where I spend the most time, just because I don't want my students to talk trivially about the results of any model, right? So I do spend a lot of time here. And of course, if you can, something very cool about BigML is the ability to explain your model and the predictions, right? So what's important in the model and what's important in a prediction in particular that you're making. This is very important. If you can't explain any you just it just happened, right? That this is what I predict. I don't think this gives a good expression, right? So a good impression. I'm sorry, for our students. So I tend to spend a lot of time there, right? We use tangible projects, a company like Lumo, predict and manage flight disruptions. You go to BigML, and there's a data set, US carrier flight delays. You have all this this data set with almost 1 million flights with certain features. You can build your model, and you can start making predictions for new flights, right? Of course, this is not online, but it's as very close with BigML as you can get to building this successful company that has implemented something, of course, more complex and probably taking real-time data. But I'll jump into, just because I'm taking a lot of time, but why I like BigML to be at the center of my teaching experience. First, the access to data. So we want to focus with business students on the topics that matter the most. One of them is not precisely implementing any crawler to collect data. So if there's ready to use data sets, and the process, the techniques, the habit of looking at certain things are equally implementable, either if you take a ready to use data set, or if you spend 3 months just learning on how to effectively collect data from the Twitter API. It's going to be hard for business students, and ultimately, that's not differential in the job market or in their companies. But rather, just jump right ahead into the data set is something pretty cool. Model catalog, they have a wide array of both supervised and unsupervised models. Some of them, all of them available just on one click, but of course customizable. And then the platform is built on touching the key elements that I think, right? So things like training test split is there, so it's harder to ignore, right? And reminds you of the importance of actually doing that. The explainability of the features, as I was saying before, and the confusion matrix also is really facilitates the work of the professor to let them know about the accuracy, the precision, the recall, and how are these different and important to differentiate, right? How would a typical project at class would look like? So we would start with our data set here, right, which is a data set comprising purchases of close to 500,000 customers, right? So for every customer, if you're familiar with the BigML dashboard, what we have is we have the customer ID, we have the age of that customer, we have the gender, how many purchases has made in total, since when this customer is a customer, so days been touched, days recency, meaning when was the last purchase, how many purchases. So this company has two products, right? One premium and one basic. How many purchases are premium? How many purchases are basic? If they use both or not, and a number of other features, right? So if this customer was acquired from a paid channel or from a free channel, the year of the first purchase, the month, a number of features, right? So the first thing that we would do is, of course, explore that. So what makes sense, what doesn't make sense, and for that, this histogram here is quite useful. Of course, again, this is already prepared, right? So there's no missing, there's no errors, but this is very useful when you actually upload data that you haven't treated before, right? So this is useful, but then these histograms are very helpful, right? I think I can get to the point where I show you how easy it is to get on BigML to actually build a cluster. So once you have your data set, right? You have your data set here. Let's say we're happy with so the data makes sense to us, the distribution makes sense. So of course we have very little, few customers very young, and then we start having more customers. They peak at around 32 years, and then of course we have less customers. So this is a product that is used mostly by young adults, equally split male and female, and we have a lot of new customers actually, right? So people that have less than 1 month vintage, and then a long tail, and then we have, of course, most of our sales happen in the last month as well, and then sort of again a long tail, right? Very easily you can build a model just on your data set. You go ahead and create a cluster. Let's say for simplicity, we want just 4 clusters. So all these configurations that if you need to use other frameworks like scikit-learn, or you need to sort of type most of this, so the interface is less business friendly, right? It is very easy to teach us actually, right? The way we do is I am my screen, the students are on their computers as well, and just very simply, this is going to be 2, and you can select, okay, so which features you want to use to be considered, right? So let's say we want age is definitely something that we want to look at. The gender, I don't know, it's a 50-50. Let's take the gender. We won't use total purchases just because we're going to use purchases premium and purchases basic, right? So we prefer to have those we're going to have the days vintage only. I'm not interested in if it's users of both. So basically here is, okay, cluster algorithm, look at the distance between any single point here by looking at these features that I'm telling you to look at, right? And ignore the others, right? And we're going to be interested in, when was the first purchase year, right? To see if there's anything on the vintage of the customers that we should know about. This is going to be fast. Oh, actually, it is here because I know we were going to be in a rush, right? Then, so the 4 clusters have been created already, right? And now what? Well, first, the visual representations of the cluster is it's quite self-explanatory, right? So the clusters are not very close one to another, right? So this is information that is easily interpretable by non-technical students, meaning these 4 doesn't resemble a lot to themselves. And then the size of the bubble represents the number of instances on every cluster. And just by tapping on every cluster, you can get an idea of how its centroid looks like, right? So how the typical or the typical customer, let's say, belonging to this cluster looks like. So in this case, we have this small cluster here, only 30,000 instances out of our 500 million, out of our 500,000. But these are customers on the high-end range of age, right? So they are here in our age distribution. So let's say older customers, predominantly male, that join the the first purchase, let's say, was done almost 2 years ago. They tend to purchase a lot of premium products, right? But also basic products, right? But they are strong acquirers of premium products, right? 4 purchases on average for that cluster. Whereas if we go here, which is one of probably the further cluster, here this cluster, the centroid is a much younger individual, right? It's like 20 years younger. It's female as compared to male. They also joined like slightly over a year ago, but they purchased much less. So on average, 1.5 items, and mostly basic products, right? Which it's interesting. We see, all right. So we seem to have old customers male. They seem to be purchasing more purchases products, while younger customers female, they seem to be purchasing very little premium products together with just a few purchases, just one purchase, right? So basically these are people that made the first purchase and never purchase again, right? What's the output of this? Maybe maybe this is not something that we can do anything in particular with it. So the process will be, okay, try letting the algorithm try new features or more features. So we won't have the time right now, but you can create new features. Maybe instead of the age, we can create group categories. So instead of treating age as a continuous variable, treat it as a categorical value, creating babies, young adults, and older adults, and that way see if we can. But as you can see, and this is my corollary, it's a very intuitive tool that allows you to go through all that discussion and create models and experiment, and on the clustering side, you can also make predictions and see to which cluster a new set of customers belongs, and see if that makes any sense for you. So that's why it's at the center of my teaching experience, and happy to answer any questions that you have later on how I make the most out of it.